Hello students. In today's lesson, you will be able to understand the absolute value of a number as its distance from zero on the number line and use it to find the magnitude of a positive and negative number in a real-world situation. What is absolute value? The absolute value is the distance a number is from zero. For example, positive 2 is 2 units away from zero. Absolute value of positive 2 is 2. Another example would be negative 3. Negative 3 is 3 units away from 0. Therefore, the absolute value is 3. Now let's take a look at the term magnitude. The magnitude of a number is the absolute value of its measure. For example, the magnitude of 10 is 10, and the magnitude of negative 10 becomes the absolute value of negative 10, which is also 10. We will review this later in the lesson, so please refer back to this slide. Please turn in your packet to page S.42. So let's look at the opening exercise. In this exercise, you will record two different rational numbers that are the same distance from zero. So I would like for you to pause the video at this time and take a moment to record two different rational numbers that are the same distance from zero. Okay. So I have chosen two sets of rational numbers that are the same distance from zero. So the two sets I've chosen are negative 3 and positive 3. Negative 3 and positive 3. So if you take a look at the number line and you start at 0, you will notice that positive 3 is 1, 2, 3 units to the right of 0. And negative 3 is 1, 2, 3 units to the left, so they are both the same distance from 0. Another set of numbers would be 6 and negative 6. So if you take a look at 0 and count to 6, 1, 2, 3, 4, 5, 6. So there are 6 units from 0. And let's go to negative 6. There are 1, 2, 3, 4, 5, 6 units to the left of negative 6. So the absolute value of 6, or the distance away from 0 for both of these numbers, is 6. And the distance from 0 for negative 3 and positive 3 is 3. So two things you should notice about these two pairs of numbers. They are opposites. Also, both pairs are the same distance from 0. Now let's take a look at example 1. We just saw that every number and its opposite are the same distance from 0 on the number line. In other words, a number and its opposites have the same absolute value. So what is the absolute value of 5? Well, if I were to look at this number line, I notice that starting from 0, I can count 1, 2, 3, 4, 5. So the absolute value of 5 is 5. What is the absolute value of negative 5? Well, negative 5 is here, so if I were to start at 0 and count to negative 5, I would get 1, 2, 3, 4, 5. So the absolute value of negative 5 is also 5. What is the absolute value of 0? Well, if you notice, there is no other 0. So 0 is the only number that has its own absolute value. So the absolute value of 0 is 0. Now, notice the two little bars on either side of 10. This is how you notate the absolute value of a number. So let's look at example 1. The absolute value of 10 is written as absolute value of 10. On the number line, count the number of units from 10 to 0. How many units is 10 from 0? Well, if you look at the number line that's already drawn, you can see that there are 10 units away from 10. So the absolute value of 10 is 10. What other number has an absolute value of 10 and why? Well, if you remember that the opposites have the same absolute value, Therefore, negative 10 also has an absolute value of 10. Now turning your packet to S.43, exercises 1 through 3. Let's look at exercise 1. In this example, it gives you a number, negative 6, and you are to find the absolute value. On the other side, you are to find a different number with the same absolute value. So let's look at the first one, negative 6. If you were to start at 0 and count to negative 6, 1, 2, 3, 4, 5, 6, you notice that negative 6 is 6 units away from 0, so the absolute value is 6. Now, if you recall from our previous example, opposites have the same absolute value. So a different number with the same absolute value would be the opposite of negative 6, which is 6. Now, I would like you to pause the video at this time and take 1 minute to fill in exercises 2 and 3. At this time, you should have filled in the rest of the chart for exercises 2 through 3. For number 2, you should have 8 and negative 8. And number 3, you should have 1 and 1. Okay, now let's look at example 2. Mrs. Owens received a call from her bank because she had a checkbook balance of negative 45. What was the magnitude of the amount overdrawn? If you recall the definition for the magnitude of a number, the magnitude of a measurement is the absolute value of its measure. So we remember what absolute value is. We would start at 0 and we would move to 45. And that would mean that we are 45 units to the left of 0. Therefore, the absolute value of negative 45 is 45, and therefore the magnitude is also 45. Now, what does that mean? That means in terms of real life, you would not say, I have overdrawn negative $45, but you would say, I have overdrawn or taken out more than $45. Please turn in your packet to the last page where it says Lesson 11, Teacher Example. Alright, let's read the example. It says, Daniel and his family owned a smartphone repair shop. On an average week, the family earns about $2,000 from repairs done for customers. Since the holidays are near, business has been picking up. Last week, they earned $3,000 above their average earnings. After the holidays, the family usually expects to see earnings fall to about $1,500 below their average earnings. In Part A, you're going to locate and label the earnings from last week and the earnings expected after the holidays on the vertical number line. The average earnings represent 0. Write a rational number to represent each amount on the number line. So let's look at the exercise. So the information that they gave us, they said that the average week the family earns $2,000 on the average week. They also said that last week they earned $3,000 above average. After the holidays, the family usually expects to see earnings fall to $1,500 below their average. So let's label our number line. So it tells us in directions that average weekly earnings equals 0. So we're going to represent the average earnings by labeling the number line 0. If you recall, our vertical number line increases from bottom to top on a vertical line. So from 0, we know we're going to count up. So let's label this 1,000, 2,000, 3,000, 4,000, and 5,000. So let's start at 0 and let's label our negatives. Negative 1,000, negative 2,000, negative 3,000, negative 4,000, and negative 5,000. So they said that the 0 represents our average earnings. But last week, the earnings expected was 3,000 above. So 3,000 above average would be here. And I'm going to label that last week. And after the holidays, they said 1,500 below. So we're going to start at 0. We're going to move down to 1,000. Halfway between 1,000 and 2,000 is negative 1,500. And this represents after holidays. Alright, so now we have labeled our number line. Let's go ahead and answer the questions. Holiday earnings last week is the absolute value of 3,000, which equals 3,000. After the holiday earnings is negative 1,500. The absolute value of that is positive 1,500. Now let's look at part B. Use absolute value to represent the distance on the number line of each amount from the average earnings. So use the absolute value to represent the distance on the number line of each amount from the average earnings. So the distance from the average earning to the holiday earnings, if we look from 0, is 1, 2, 3, 3,000. And the distance from the average earnings to the after holiday earnings is 1,500. Part C, what is the distance between the holiday earnings and after holiday earnings? So the holiday earnings in here, after holiday earnings are here. So if we add them up, we have 3,000 plus 1,500, and our answer is 4,500. Okay, thank you. That's all I have today.